Hello everyone, I'm thrilled to be part of Conf42 and have the chance to share my insights of one of the most exciting intersections of creativity and technology, algorithmic art using JavaScript. This conference brings together people passionate about tech, and I hope that by the end of the session you'll see how JavaScript is not only a tool for development, but also a medium of artistic expression as well. Let's dive into this journey together and explore the fascinating world of where code becomes art. Think back to when you were a child. Remember how naturally drawing came to you? However, it was doodles in the margins or of your school notebook, crayons on paper, or even drawing in the sand at the beach. What did you drawing mean to you back then? For many of us, drawing as a child was about pure creativity, a way to express ourselves without worrying about the rules or being judged. It was about exploring our imagination freely. But as we grow older, many of us stop drawing. Why is that? Does the fear of imperfection creep in? Do we become too focused on what others think? Today, I want to invite you to reconnect with that creativity freedom. It's time to using the power of code. The table contents, what I want to talk with you today. Get to know me. I start sharing a bit about myself, who I am, what brought me to this point, and why I'm passionate about both technology and art. This will give you a sense of perspective I'm bringing to this to understanding algorithmic art. Next, we'll dive into what algorithmic art is. I'll explain how algorithmic creative coding come together to form a unique blend of art and technology, and how this field is transforming the way we think about creativity. Exploring JavaScript for creative coding. After that, I introduce you a powerful JavaScript library, P5TS, that you can use to start creating algorithmic art by yourself. You'll see how tool enables artists and coders alike to experiment with visual interactions. Resources for experimentations. I also share some great resources where you can experiment continuous learning, including platforms like Open Processing, that offers inspirations, tutorials, and examples from the creative coding community. Conclusions and reflections. As we near the end of the talk, I offer some deep reflection of how algorithmic art challenge our traditional ideas of art, and how you can incorporate this form of creativity into your own projects. And finally, I'll provide my list of references so you can explore these topics further and see the sources behind the concept and ideas was discussed today. I'm Francisca Beatriz Medina Concha, and you can find me on my social networks. On LinkedIn, I'm listed by my full name, Francisca Beatriz Medina Concha. But if you prefer Instagram, you can find me at franny.b. Franny.b. Instagram is my platform. So if you happen to take photos, screenshots, or whatever during this session or while experiment with algorithmic art, I really appreciate if you tag me. It's always great to stay connected and share our creative journeys. My roles. I'm currently role as UX and front-end leader at LATAM Airlines. I'm responsible for overseeing the design and development of user interface with our data visualization team. As a speaker, I have the opportunity to share my knowledge, passion for technology at conferences like GSCon Chile. As a volunteer for Women Tech Makers, I support initiatives that empower women in technology through mentorship, education, and community building. Let me tell you a bit more about who I am. I'm a variety career designer, web developer, teacher, and now leader. But beyond the tech, I always love making art and craft with my hands. No, I'm definitely not a robot. I'm a cute, emotional person who finds joy in creative, both digital and physical. I'm from Santiago de Chile, and while Santiago is our capital, it's important to know that Santiago is not Chile. Chile is a long and diverse country with so much to offer beyond this capital. For those who wonder where exactly Chile, we are the southernmost country in the world, stretching all the way down to Antarctica. We speak Spanish, so I want to apologize in my advance if my English is not perfect. Thank you for understanding as I present this talk is my second language. Personal motivation. My personal journey into the world of art and technology started in a childhood. I was a shy kid who loved art and dreamed of becoming an artist. That passion led me to study design at the university. But during my time at the university, I had a crisis. I started to feel like maybe this was then I discovered web development, which rekindled my childhood love of creative and building things. That turning point led my course called Creative Programming for Design. I became teaching assistant in that class, inspired by one of my professors, Ricardo Vega. So this talk is for you, Ricardo. Through this journey, I made amazing connections, like my friend Valentina Gaete, who was one of the students in that class. Vale went into pursue a master's degree in Germany, and she always tells me that this class changes her life. My own preliminary thesis at draft was about algorithmic logos, which sparked my interest in merging art and technology. Now, as a professor, I strive my students the same inspiration and opportunities that I received. I'm not currently in a full creative role. My goal is to bring creative back to my work and help the students to involve technology to open up opportunities for themselves. My journey to where I am has not been any but linear. When I started, I didn't imagine I would become a team leader, a speaker at conferences like this, or even a volunteer empowering women and girls in tech. In fact, for a long time, I was so an introverted person, too afraid to speak up or take on challenges that feels beyond my reach. I used to see leadership and public speaking as things other people did. People were naturally outgoing and confident, not someone like me. But everything began to change when I realized that growth comes from stepping outside the comfort zone. My roles today is whenever the team leader, mentorship, or giving talks didn't come because I had everything to figure it out. They became I took risks, embraced filters, and learned to trust my own voice. Along the way, I discovered incredible satisfaction of helping others, especially women in tech, to find their place in a world that often feels like it's not made for us. That's why I became a volunteer and a speaker, to share what I've learned and help others on their own journeys. This talk is part of that mission, to inspire you to see how your own potential. So let's start with the basic. What is an algorithm? I'm sure that most of you have come across this term, but let me sure we are all in the same page. An algorithm is essential a set of instructions, a step-by-step process solving a problem or performing a task. It's like a recipe of cake. There are specific steps to follow to reach the desired outcome. In the world of programming, algorithms are what make computers capable of performing complex operations. Whether you realize it or not, algorithms are everywhere, from recommending what video you should watch next to controlling traffic lights, and even in the art we are about to create. Now, here's a big question. What is art? Definitively, art is something philosophers and artists have been debating for centuries, and there's no answer. For some, art is about beauty and aesthetics. For others, it's about emotion or making a statement. Art can be a way of seeing the world of expression, something that words can capture. Here are some aspects to consider: creative expression, aesthetic value, mediums and forms, interpretation and perception, innovation and tradition, and cultural significance. The way we create and experiment art has evolved dramatically in the recent years. With the rise of digital technology, art now have access to tools that previous generations could have imagined. Today, art is confined to the paint or canvas or sculpture in marble. Its pixels, code, and even virtual spaces are allows to blend mediums to collaborate in ways that were never possible before. The boundaries between art, design, and technology are becoming increasingly fluid. And algorithmic art is a perfect example of this new frontier. where creative meets competition. Algorithmic art represents a unique form or artistic expression where technology and programming play a fundamental role in the creation of the work. This type of art is notable for its ability to transform algorithmic art and data into visual and sensory experiences, often challenging our traditional perception of art. The art is a perfect example of how art and technology can merge in the way that are both precise and poetic. It leverages the computational power of computers to create pieces that would be impossible or less extremely time-consuming to make by hand. Artists know as algorithms use the code design algorithms that generate visual works. These algorithms can produce intricate patterns, complex geometries, or even simulation of natural process. And the beauty lies in the fact that often no two outputs are the same. The art evolves based on the algorithm logic, input, and randomness. This art pushes the boundaries of what traditional think of as creativity, offering new ways to explore and express ideas. An algorist is an artist who uses algorithms as part of their creative process. But being an algorithm is more than just write code. It's about seeing code as a tool for expression. For these artists, algorithms becomes their paintbrushes, and the computer screen, they use code to generate art, creating everything from abstract design to interactive visualization. An algorithm doesn't just program for function. They program for building meaning, embracing the unpredictable ambition that becomes its algorithmic process. In September 1995, the term algorithm was coined by the artist Jean-Pierre Herbert. He wanted to describe artists who use algorithms as the primitive tool for creating art. At the time, it was a new concept, combining the world of fine art with the precision of computer science. Herbert and others in the field recognized that algorithms could do more than solve mathematical problems. They could be used to explore creative in new dynamic ways. His work set a stage for the explosion of digital art that we're seeing today, and the term algorithm has become to symbolize the fusion of these two worlds. Now we have JavaScript. JavaScript is one of the most versatile and widely used programming languages today. Originally created for adding interactive to websites, it had grown far beyond that. JavaScript now powers everything from the web, apps, servers, and yes, it even becomes power tool for creating art. What makes JavaScript special for our purpose is flexibility. It's accessible enough for beginners to pick up quickly, but powerful enough for complex artistic projects. JavaScript is an incredibly powerful language, but what makes it even more versatile is the vast ecosystem of libraries. There are libraries for everything. Let's say you work on a website. You go libraries like React or Vue to build dynamic user interface. Need to manage massive amounts of data? There's Beatriz for data visualization, or libraries like loaders for simple complex data manipulation. Want to animate? Greens has you covered for sick animation. Even if you need to handle something mundane as date and times, don't worry, there's Moment.js to help you out. We even have libraries for libraries. Tools like Webfar or Babel exist to optimize and bundle all your code together, making everything run smoother. So yes, JavaScript developers often joke that if there's a problem, there's probably already a library to solve it. But what about art? Yes, even for creating art, there's libraries. Today we focus on one of those, P5.js. This library was specifically designed to bring the power of coding into the hands of artists and creatives. Whenever you design interactive visuals, generate patterns of something complex, completely unexpected. P5.js unlocks a world of artistic possibilities through code. P5.js is a fantastic library created by Lauren McCartney, and it was designed to make coding accessible to artists, designers, educators, and anyone interested in the creative coding. Lauren's vision was to make a tool that allowed people to create visual art with code without needing to be an expert programmer. It's built on the top of processing, a popular framework used by creative code, and it brings all of the power into the JavaScript ecosystem. There's a story of P5.js. 2001, processing was developed by Casey Ryan, an artist, and Ben Fry, data scientist. In 2001, Casey Ryan and Ben Fry, both students at the MIT Media Lab, create processing. Their goal was to develop a software, sketchbook, and a language that would serve the electronic art and visual design communities. Processing was designed to be an easy-to-use language for artists and designers, combining visual programming environment with a simple syntax to encourage experimentation and creativity. In 2008, Processing.js was developed by John Reesen, a programmer. In 2008, John Reesen, known for his work on jQuery, developed the developer Processing.js. This was a JavaScript port for processing, allowing processing code to run natively in web browsers without the need for Java plugins. Processing.js made it easier to integrate processing sketches into the web page and brought the capabilities of processing to a broader audience. In 2013, P5 was developed by Laura McCartney, artist and programmer. Laura McCartney developed P5.js. P5.js is a JavaScript library that aims to make coding accessible for artists, designers, educators, and beginners. It is a station of processing for the web with a focus on making code more approachable and inclusive. McCartney works on P5.js, emphasizes interactive and creativity. Building on legacy of processing will leverage modern web technologies. Between 2014 and 2015, some Java and processing updates made it difficult for Processing.js to remain used. Between these days, updates to Java and processing itself create incompatibility issues for Processing.js. These updates make it challenging to maintain and use Processing.js, leading to a decline in it as the community began to shift towards more robust solutions like P5.js, which were better suited to evolving web environments. Processing.js stopped active development in 2016. By 2016, active development of processing has ceased. The community and developers recognized that P5.js was a more viable option for web-based visual programming. P5.js provides a more modern and versatile platform, prompting the focus to shift entirely towards its development and support. In 2018, the PF.js online editor was launched. This online editor made it even easier for users to start coding with PF.js without needing to install any software. The editor provides a user-friendly interface, fostering a collaborative and accessible environment to learn and creative coding. It became a significant resource for educators and learners worldwide. In 2020, both processing and PF.js continued to be actively used in development. Processing continued to evolve as a powerful tool for creating coding in Java, while P5.js thrived as its JavaScript counterpart for web-based projects. The ongoing development of both platforms ensured that they remain relevant and valuable resource for artists, designers, and programmers. What are the differences between processing and P5? Processing was based in Java with its own IDE. What are its strengths? Is to use. Designed for artists and non-programmers, processing has a simple syntax that's easy to learn. Performance as a Java-based platform, processing often offers better performance for more computationally intensive tasks. Community and libraries. Processing has a large community and many libraries available for tasks such as computer vision, data visualization, and more. Desktop application. Great for creating standalone desktop applications and installation. What are its weaknesses? Web integration, less trade-off to integrate web technology compared to P5.js. Processing is somewhat isolated from modern JavaScript ecosystem, which include powerful tools and libraries for web development. P5.js is a JavaScript library, often used with web-based IDE or integrated into web projects. What are its strengths? Web integration. P5.js is designed to work seamless with the web technologies, making it ideal for interactive web-based projects. Accessibility. Since it's run in the browser, P5.js projects are easily accessible and shareable via URL. Leverage the power of modern JavaScript ecosystem, including tools, libraries, and frameworks like React, Vue, and D3 learning resources. Extensive documentation and tutorial, particularly suitable for beginners learning coding through creative problems. Weakness. As a JavaScript library, P5.js might not perform as well as processing for more computational intensive tasks. Creating a standalone desktop application can be more complex compared to processing. With P5.js, you are still using the same JavaScript basics. Functions, variables, loops, and logic, just like any other program. But there's an exciting part. Instead of outputting data or perform calculation, you are creating visual experience directly on canvas. When you use P5.js, it generates an HTML file with a canvas element, and that canvas becomes your virtual paper. Everything you draw, animate, or interact with happens inside this canvas, allowing you to bring your code to life in a visual way. Functions like setup and draw are essential in defining what appears on the canvas. Setup runs once, like setting the and draw is where the action happens. It's like the function that gets called continuously to create animation or update your visual frame by frame. Essentially, every line of code you write is an instruction for what gets drawn onto that canvas, making coding direct and creative process. Let's take a look at this sample from the P5.js website that creates a star shape. The beauty of this code is in its simplicity. It uses basic geometric principles and loop to generate points of a star, placing each vertex with precise mathematical accuracy. By routing and scale, you can create a pattern that feels both calculated and organic at the same time. What's powerful here is that just a few lines of code can produce something visually striking. One of the most exciting aspects of P5.js is the ability to create interactive experience. With just a few lines of code, you can make your artwork respond to user input, whether it's through the mouse, keyboard, or even the sound. For example, you can track the position of the mouse and use that data to move elements on the canvas or change colors dynamically. Imagine creating a painting that reacts to where you click in or draw your mouse across the screen. With P5.js, interaction is as simple as using built-in functions like Muse X and Muse I to detect the position of the mouse, or key preset to respond to the keyboard inputs. You can even incorporate audio input to visualize sound waves or create artwork that reacts to external sounds. The potential for creation is limitless, making your audience a part of creative process. JS is particularly well suited for creating geometric patterns, which are often visually captivating and mathematical precise. By combining shapes like circles, squares, and triangles with loops and transformations, you can create intricate designs that would be incredibly difficult to write by hand. Whether it's stealing patterns, mandalas, or optical illusion, the presence of the computer allows you to play with symmetry, repetition, and scale in a way that results in measurable visuals. And because you are working with code, you can easily tweak parameters like size, color, or rotation of elements to explore endless variations of the same pattern. Fractals and interactive systems are another fascinating area to explore with P5.js. These are patterns that repeat themselves at a different scale, often resulting in highly detailed and complex structures. A classic example is the Mandelbrot set or the Sierpinski triangle. With P5.js, you can use recursion, where a function calls itself, to generate fractals that reveal infinite complexity as you zoom in or out. These fractal designs are not only beautiful, but also demonstrate the power of mathematics and in creating art. Data visualization is another exciting application of 5DS. Data visualization is another exciting application of P5DS. By mapping data to visual elements like shape, colors, and size, you can create visual representations of complete datasets that are easy to understand. Whenever you're working with scientific data, social media metrics, or any type of your information, P5DS can help you turn numbers into visuals. For example, you can create bar charts, scatter plots, or even abstract visualization where data points become a part of larger artistic composition. This approach not only makes data more engaging, but also allows you to tell story through your visuals. P5DS can also use to simulate natural phenomena, from the movement of particles to behavior of flock of birds. You can model real-world systems using code. By applying rules that mimic natural processes, you can create simulations that behave in a life-like ways. For example, you can simulate the growth of plants, the flow of water, or even the way animals move in groups. There are simulations that are not only visually interesting, but you can provide insight into underlying mechanics of nature, all while pushing the boundaries of what art can represent. Randomness is a key ingredient in many forms of algorithmic art. By incorporating randomness into your code, you can create pieces that never the same twice. For example, you could generate a forest trees with each tree as a unique shape, or create abstract art where colors and shape appears in unpredictable. P5DS make easy to add randomness with function like random that introduce variables in size, position, or color. The element of chance in your data adds a layer of spontaneity, allowing for surprise and often beautiful results. Beyond just reacting to user input, P5DS allows for fully interactive generation where the user can actively share the artwork. For example, you can create a drawing tool that viewer become the artist, clicking and drawing into their shape on the canvas. Or you can build environments where the user control and the evolution of patterns, adjusting parameters in real time to influence what happens on the screen. This blur the line between creator and audience, turning the artistic process into collaborative experiences. One of the most famous examples of algorithmic art is Conway's Game of Life, which is a type of cellular automaton. In this simulation, simple rules dictate whenever a cell on a grid is alive or dead, and from those rules, incredibly complex patterns emerge over time. What makes this fascinating is that it mimics real-world process, like the growth of a population for the spread for fires, all from a few basic rules. The Game of Life has been a source of inspiration for artists and science alike. And with P5DS, you can easily create your own version of the cellular automatic to explore beauty and simplify rule-based system. Now, we have covered a wide range of possibilities. I want to share some resources that will help you dive deeper into the world of algorithmic art with P5DS. Whenever you are a beginner or experienced coder, the resource will provide inspiration, tutorials, and tools to help you to create your own projects. One of the best platforms to explore and share your P5DS creation is Open Processing. It's an online community where artists and coders share their projects, providing inspiration and learning opportunities. You can browse thousands of sketches, many of which are open source, meaning you can see the code behind the visuals, learn from it, and even remix it to create something new. Open processing is valuable not just for showcasing work, but for fostering collaboration and experimentation with the creative coding community. Let's look about this sketch on open processing. This sketch uses basic shape repetition and randomness to create an organic looking pattern. The code starts by definition simple shapes like circles and lines, then applies randomness to their position, size, and color. What do you guess is visually interesting? Piece that looks like it was drawn by hand, even though it's entirely generated by code. Next, we have this example, which showcases how P5.js can be used to create fluid continuous motion. This state simulates particles moving across the canvas, influenced by invisible forces like gravity or wind. The code relies on vector to define the position and velocity of each particle, creating a dynamic flowing visual that feels almost alive. It's a great example of how PF can bring movement and energy into your art. Finally, let's look at that example. This sketch demonstrates that the power of convenient randomness with control. The artist uses randomness to generate abstract shapes, but also add parameters that control how those shapes evolve every time. The result is a piece that feels both chaotic and intentional, where every refresh of the page brings something new, yet grounded by the same underlying structure. As we see today, algorithmic art is a powerful way to merge creativity and technology. It also allowed us to explore new forms of expression, where the artist and the code collaborate to create something unique. What excites me most about this field is that it challenges the traditional idea of art. It invites us to see beautiful in logic, randomness, and in the unexpected. Algorithmic art reminds us that creativity doesn't have to be confined to paintbrushes or sculpting tools. It can also live in the code we write. I know I've covered a lot of ground today, and if you want to dig deeper, there's an excellent resource that I've referenced through this talk. If you enjoyed this talk, want to see more of my work, or you have a question about getting started with algorithmic art, feel free to follow me on Instagram. I'd love to share connects and see what amazing creations you come up with.